G'day there, you're watching the Aussie BIM Guru, and today I'm going to be talking about Dynamo user interfaces. It's actually a presentation that I've done in person at a user group in my hometown of Sydney, but I thought I'd put a version of it up on my channel as well because it's quite educational. So today I'll sort of skip over most of the stuff about me because it's not as relevant to YouTube, but I'll be focusing mostly on Dynamo Player, and a custom package called Data Shapes, which is the emphasis of the presentation, and ultimately how this can be done, not just what and why. A lot of presentations talk too much about things and don't show them in action. I actually show these people videos of what I do, and I'll also put this in the presentation here as well. So, walking the walk. Anyway, just quickly about me. So my name's Gavin and I'm an architecturally focused BIM manager. I'm architecturally trained with a master's, and I've been working for about 8 years now in the industry. And I've been attending this user group for about a year now. And I also have my YouTube channel, which you're watching right now. But we're focusing on Dynamo today. So I guess most of you probably know what Dynamo is. For those of you that don't, it's an open source tool which uses visual coding in order to script and relate back to BIM software such as Revit. So it's quite powerful because it really lowers the entry point of coding for us. And it's in Revit, it's on the Manage tab, just where it's highlighted here typically, unless you're in an earlier version. So graphical programming or visual scripting or visual coding is basically an easier way to code for people that aren't familiar with coding environments. So you can see on the left here, there's a C function, I believe that is, and most of that doesn't really make that much sense to me, even if it is telling me that time is the best teacher. Hardy ha ha ha, funny funny. But really, I don't have the time to learn that, ironically. But on the right, you can see a program called Scratch, which is a form of visual coding. So you have a lot of prompts and ways of seeing how your code is working, and it's very word and visual based versus the coding environment where everything is syntax based. If I make one space in the wrong spot, code doesn't work, which is a big problem. Whereas this is literally a program that I know people as young as 3 are learning in little technical mini schools now. So it's a brilliant way to bring people into the world of coding and probably take our jobs in the long run as well. So why do we use Dynamo? So it's accessible to all Revit users. It's free and it comes with Revit, so there's no excuse not to use it. It'll save you a lot of time and it'll make you much more efficient. And it will standardize your workflows, so scripts will force things to run in particular ways. And it does support Python coding, so if you know Python, that will help. And it's fun most of the time. Occasionally things don't work, there's bugs, typical scripting issues, but far less than the frustration point of a harder language to learn, such as C#. So I guess, here's me, computational designer. Here's everyone else, and they're running their square wheels. So a lot of people I see don't have the time for Dynamo, but ironically they spend a lot of time doing things in very unintelligent ways, which actually wastes their time. So they're busy being busy, and they could actually save more time if they were just a little bit less busy for a little while. Not leaving at 5:30 probably. So don't be these guys. Try to keep up with the way the software is moving if you're using software. And this is I think it's a C#, C# script or C++ script in Visual Studio. You can see it's very intense. It's very hard to learn how to script just by looking at that. So most people would look at that if they're learning to code, and they'd say, no, not interested, and off they go. So it's really important to make sure that you don't scare users away when you're trying to teach them how to code. So avoid vertical learning curves. So how to get to Dynamo. So most of you probably know on the Dynamo website, you just go to Get Dynamo and you pick your latest version and download. Or you can go to Builds and pick another build of Dynamo to install. There's also a great forum for Dynamo. If you have any questions or you want to contribute anything, this is a great place to do it. Very busy forum. So the Dynamo Primer as well is a good way to learn Dynamo. I got a lot of tips and tricks, and it's got a very good start to finish workflow. There's also a Dynamo learning series on my channel. So anyway, how does Dynamo logic work? So, and don't worry, for anyone that thinks this is very basic, don't worry, I will get past this soon. But you can see here a basic script in action. So you can see inputs going into a list, and we're watching that data and then we're concatenating into a sentence. So essentially we have inputs, we have functions, and we have outputs. And we really just flow our data in this direction from left to right through our visual script. So we're not going top to bottom like most scripts would. It's a different way of looking at coding. So Dynamo uses what's called nodes in order to manage its data. So you can see a lot of components here in this node. So you have like a sub list inside of a list. You have levels within that list, and you're counting your data as well. So you can see I have 4 items there. So that's sort of like the biology of a node in Dynamo. So a node, an input, an output, and then what we call wires, which connect all of them together. And basically this is how our data moves through. It goes in, processes, and flows out of the output. So that's in principle how Dynamo works at a high level. So there's a problematic example we're going to pick today for our case study in order to show user interfaces that can be solved by using Dynamo. So most of you have probably dealt with revisions before and having to add them to sheets, maybe a lot of sheets. Let's say you're doing a Friday issue, you've got a revision for the day and you need to go and add them to, say, 300 sheets. So you have to go to revisions on sheet, edit, then you have to go in and tick the revision that you want. And you have to do that every time for every sheet. What a pain. So you sort of end up feeling a bit like this guy. Why can't I hold all these revisions? There's just too much work to do. It's very boring, very monotonous. There's a lot of tools that can solve this problem, but Dynamo can as well. So we're going to just do a quick demonstration. I'm going to switch to video mode so you can see the full screen, and I'll show you just how to set up that basic script. So off we go. Okay, so we have a Revit model here where I've just set up a bunch of sheets. This is just a sample project. And as you can see, I've just configured the title block so you can see which revision each sheet is currently sitting on. So they're all currently sitting on revision 1. So what we're going to do is we're going to open up Dynamo, and we're just going to build a really simple script that can enable us to change the revisions of these sheets by applying a revision to a set of sheets, essentially. Dynamo takes a little while to boot up the first time usually, but once you're in, you're in. Okay, so I'm using version 2.0.3 at the moment. Noting that earlier versions such as Revit 2016 will need to use version 1, where the script may not quite function the same way. So we're just going to save our workspace as a new script, and then we're going to get started. So I'm just going to move my geometry preview out of the way, just so I'm working on white space. Okay, so you've got here basically a set of nodes. This is basically our library that's available, and then below that you have a whole bunch of custom nodes, or add-ons as we call them. So these are built by the Dynamo community, and they usually have much more advanced functions within them, typically written in Python, so they're much more complex and they let you do a lot more things. So we will use a couple of custom nodes today, but basically you can find them in packages essentially. So you can see here I've got a bunch of installed packages in Dynamo, and I've got a package manager where I can search for them. So you can see here that I'm just, searching for anything really. There's a lot of good ones, a lot of bad ones. It's open source, so anyone can upload. There's very little moderation. In this case, we're using, say, Archilab, and Archilab's, a very thorough package that's got a lot of versions and builds. So as Dynamo progresses, people typically release add-ons to these as well. Anyway, so we'll start building our script. So we're going to get started. That's just a code block. That's basically just like a block of code if you want to write very flexible code. But we're going to deal mostly with nodes. So we're going to get our views sheet set as a drop-down. And this basically lets us pick from a set of views. So we're going to have to work with sheet sets just because of the way Dynamo works. But we will be able to work around that in later versions of this script, which we enhance with user interfaces. So we're just going to go and get the views from that view sheet set. And in this case, the views are actually sheets because sheet sets can have views and sheets. So I've already pre-configured this to have all my views or sheets. So you see here, if I go to my sheet set, you can see I've already pre-selected. I'll make a new set actually. I'll just make a fresh one, sheet set demo. And we'll just pick all but I think one of the sheets for the sheet set maybe. Just so you can see how it impacts all but one. There you go, so you can see we've chucked a bunch of views in there as well. Because what we're going to have to do is actually manage our list, because very often sheet and view sets can have sheets and views. It's really important in Dynamo to build your scripts so that they don't have the potential to be broken by other people. So for example, if you just built it to let sheets and views through and you assumed no one's ever going to put views in their sheet set, they might break the script and send them through by accident and do some damage to their model. So what we need to do here is actually filter out our views. So we're going to get the category of all these views, which we're treating as elements, and you'll see that now we get a list of what those are, and then we're just going to compare these. So we're going to turn that into a string, which is basically text, And we're going to use a comparison node in this case as well. I'm just going to show you data types here. So we could have used the element category, but the reason we're not is because you'll see that if I check the category of this element, it's not the same as a piece of text, which we want to compare it to. So you see there, it's a Revit element category, but here it's a string. So that's why we've converted our data type. Data types are really critical to understand in any coding language, because you can obviously only process data that is in the same type of data as something else. So here we're just going to double check what is sheets and what is not sheets. We're going to use an equals node to get basically a true or a false. And you'll see here that depending on whether it's sheets or views, we end up with trues or falses. I'm going a little bit slower than I usually would on my channel, so just bear with me. I was presenting to a lot of new users to Dynamo that needed this to be explained, I think. But what I'm going to use now is one of my favorite nodes, which is a filter by Boolean mask. So it takes a list and it will basically split up results based on whether true or false is fed into the mask. So essentially, like a Photoshop mask, it's black and white, so you're separating them into two lists. So this is how we just get our sheets. So we're essentially getting everything that's categories equal to sheets out of here. So you'll see I'll just use a watch node to preview my results, and you'll see what we end up with. Great. So that's pretty much the first step of our script. We've got all our sheets that we want to apply revisions to, but now we need to get the revision and also the node that lets us apply revisions to sheets. So we'll just make that a group. So you can right click and select nodes in Dynamo to put them in a single group. And this is sort of a really basic way of showing your users how they can go about the script and understand each building block that makes it function. Okay, so we're going to get another drop down called select revision. So this is the revision that we're going to apply or remove from our sheets using the script. So you can see that we're going to take everything in the sheet set. So we only have to do one thing, which is create a sheet set. And in this case, we're just going to add a Boolean because we need to say whether we want to add the revisions or remove the revisions. If we made a tool that just added the revisions, it's not as functional as it could be because the process of removing or adding revisions is very similar in Dynamo, so it makes sense to put the two together. We're just making another true false that we'll use just a little bit later to turn on another node. But at this point, we're going to call on the add revisions to sheet node, and this is actually a custom node. So this, I believe, comes from the Archilab package. Yes, so you can see there that this isn't a node that comes with Dynamo by default. So it's really important to understand that maybe should be identified in our script. So if someone opens our script and they don't have Archilab, they know where that came from, just in case. And we can go back and also identify this view sheet set views node as Clockwork, because Clockwork is another custom package. At this point, we're also going to add the remove revisions from sheet node, also from Archilab, and then we're going to basically set up a bit of a function in order to pass one or the other through. So we're going to use what's called an if node, and this is from a package called Zebra. There was an if node in Dynamo, I think there still is, but I find that doesn't always work since version 2. So instead we go and call on Zebra's package instead, which retains the old function of this if node. Okay, so at this point we're just using this true false in order to tell the revisions to be run, because otherwise it won't run. Some people like to add those to their scripts for testing purposes so they can disable parts of their script. So what we're going to do is we're going to say if it is true, the function that we want to push through is adding revisions, and if it's false, the function we want to push through is removing revisions. So it's quite simple, essentially. And what we're going to do with that is we're then going to use a node, I believe, called list map in order to apply that function to the sheets. So list map basically says find all the nodes that are disconnected in the function that leads up to the bottom line, and take the things from the top and run it across all those elements. So it's going to take all the sheets and it's going to run them across either the true function or the false function in this case. So that's how we can backtrack a function in Dynamo. It's a bit of an advanced technique, that one. It took me a while to sort of figure that out, how that works. It's basically like an if then else, if anyone's done any Excel or Revit coding before, but it's a little bit more complicated to achieve that in Dynamo. So what we've got there is basically our output. So that will essentially run that function across all the sheets. So we've really ended up with quite a quite a nice little script here. It's quite a simple one. It's not too big. I tried to pick an example that wouldn't end up becoming a big sprawling tree of code, as a lot of Dynamo scripts tend to become in demonstrations. Just tried to keep it simple. So what I'm going to do here is I'm just going to color code these and call them my inputs, so that if someone opens the script, they understand how it works. But there we go. So if I just minimize this and put Revit on the side, you'll be able to see how this script interacts with Revit itself. So we should expect that whichever revision we choose will be applied to the sheet set. So we're just going to pick our demo sheet set, and we're just going to pick our revision. Let's just say revision 2, and we'll say yes, we want to add it, and we'll run our script. And there you go, you can see that those numbers all ticked up. So essentially the script has worked. So you can see that that's quite a powerful script. And obviously we can keep changing our inputs at this point. We can say we want to remove that revision again. We can obviously add more revisions as well, so we can really quickly work with this. But note that the sheet set is a very limiting factor in how the script works. I really don't like using sheet sets in Revit unless I really need them for something like a tool like Xrev, because they're quite a pain to maintain and keep track of. But there you go. So you can see that in this case our revisions have been applied, and I'll change my sequence in Revit so that the revisions are ordered per sheet rather than per project. So if revision 8 is the second revision, it will be at revision 2, not revision 8, for example. And there you go. So that's
as you can see in that demonstration, what we've essentially done is taken our original script, and we've taken our inputs and made them actual inputs. We've processed them, and we've taken them to an output. But there's some problems with basic scripts that you can sort of come across quite immediately when you use Dynamo a bit more. One is that the native script must be open to run it. So the user has to understand the Dynamo user interface. So immediately they don't want to learn Dynamo because they have to learn everything just to run a basic script. The user has to find the inputs as well. So for bigger scripts, that can be a problem. No matter how well you color code, some users just won't be able to spot certain aspects of the script they need to work with. And the users can obviously overwrite the script as well, which is really frustrating if you're a coder and you need someone to just come in, run the script and leave. Maybe they'll try and fix the script because it's not working, because they're not using it properly, and before you know it, your script's broken. The other limitation is only one script can be open at one time. So what's the solution to that? So one first solution that I explored is Dynamo Player. So this comes with Revit, I believe in 2017 and beyond, and it's located right next to Dynamo. If you're going to use it, it's important to understand that I always recommend opening Dynamo first in Revit and then closing it, because in the background, Dynamo's chosen its version. So you basically tell Dynamo which build you want to use. By default, if you don't pick it by opening Dynamo Player will just open the lowest version of Dynamo you have, which is usually not what you want, because usually you're building for the latest version. So from there, you basically just open Dynamo Player. So the great things about Dynamo Player, the first thing is the native script is not opened to run it. So they only need to understand how to use Dynamo Player, which is a lot simpler than Dynamo's interface. And it's very easy to access inputs, as I'll show you soon. And the user cannot overwrite the script very easily. There is an edit script button where you can jump into Dynamo, but I think people would know if they clicked it by accident. And the other thing is you can build toolboxes of scripts as well that I'll show you too. So this is Dynamo Player, so it has an active document nominated at the bottom of the interface. This is sort of docked separately to Revit. So you can navigate to your folder here. So you pick your folder, refresh Dynamo Player, and essentially each row is one of your scripts. From there, you click on this button to modify the inputs before you run the script. Not always, your script may not always have inputs, but most of them will. And then from there, you just press play to run. So essentially in Dynamo Player, there's a lot of types of inputs it can accept. So things like true falses, or booleans as we call them in Dynamo, or text inputs and file paths. And also you can see it takes on default values as well. So in that case, my default path there was my desktop, and the script remembers that. So the other things too it has is things like number sliders and outputs for feedback, and also drop-down menus where available in Dynamo. And you just press play when you're ready to go. So I'll just do a quick demonstration on how to enable Dynamo Player in a script, and then we'll move on to some more advanced user interfaces. So time for another demonstration. Okay, so we have our script here that we've just built. So you can see we've got our input still there. So what you do is you right click on what you want to make an input in Dynamo Player, and you select is input. So we're going to add our 3 inputs here, so they show up in Dynamo Player. And then we also have an output section. We can show them as outputs, but instead I'm just going to plug in this little node that I've built that basically collects a bit of data from what's happened. So it finds out how many sheets you're applying it to by going back, and it also finds the revision name, and it will basically use another if node to either say added or removed. So we're really just building a sentence there based on what's happened. So and we're just making a sentence that says this has been applied to a certain number of sheets. And we're going to basically run that as our output instead. So it's a bit more meaningful to the end user. And you can see that's how that sort of changes as those inputs change as well. There we go. You can see now it's saying removed. Okay, so we've added a really basic interface here as a result. All right, and we're just going to add something on the end. So we're going to show like a really minor interface here that you can add, which is basically just a user message. So this is from a package called Rhythm. If I unfreeze that, it's really just going to add like a little box like this that comes up after you run the script. It's up to you whether you want it to be there or not. It can be a pain for users if they don't want to keep clicking OK, but it's a great way for users that might be more concerned that maybe the script didn't do anything, because this tells them what's happened essentially, because you're taking your outputs. But anyway, that's not related to Dynamo Player. That's just a little additional trick that that's up our sleeve if we need it. Anyway, we're going to close Dynamo and boot up Dynamo Player, and we're just going to navigate to our folder that contains our script. So I'm just going to my presentation folder here at the time, and you just open the folder itself, not the file. In this case, we're just going to run the Dynamo Player for video script. And I'm just going to my inputs now. Usually the first time you open inputs, it can be a little bit slow. But I find after that, once Dynamo Player has sort of started doing its thing, it's pretty fast when you go to other scripts. So you can see here our 3 inputs. So we can pick our sheet set, we can pick our revision, and we can pick whether we want to add or remove. So quite quick. And there you go, you can run it, you can just change your settings again, and you can run it again with the same settings. So very fast, very efficient. You can remove. So yeah, it's very quick. And this is all the user needs to see.
So as you saw in that script, we did use Rhythm. It's really important to have a look at these sorts of packages because they have a lot more nodes in them than just what I showed you, but that's a little helpful one that comes from there. Another great node that Rhythm has in here is the ability to upgrade or batch upgrade families to new versions in Dynamo. So check it out. Anyway, we'll go to the next slide. All right, so what we've basically done with our script in principle is upgraded it. So we've kept everything more or less the same. We've just defined the inputs and we've added a basic message at the end. So large in part the same, but there are some limitations with Dynamo Player as well. Some that led me towards user interface creation. So the input types are quite limited. The way that they're set up is very dictated by how they're defined within Dynamo's default nodes in Revit. The stop-start function is not easily achieved, so the ability to gather some data and then keep the script running, so to stage your inputs. And a lot of users have what I call itchy trigger fingers. They're really keen to hit play without checking their inputs. And unfortunately, Dynamo Player will let you do that. So unless you build your script to be absolutely idiot-proof and make sure that the script just can't run without the inputs, you can get some scripts that people will run incorrectly. And the UI layout is quite restrictive. So the order the inputs appear in is quite random. I think it's usually defined by the order that those nodes were created in Dynamo. So that doesn't really give us a lot to work with. And it's hard to embed any sort of help in that Dynamo function. It's hard to put any text notes in there or help file hyperlinks, things that could help people understand how to run the script, like a how-to fact. So what's the solution? So a really easy to reach solution for anyone that does a bit of research is a package called Data Shapes. So it's made by a French development team that makes a lot of custom packages for Dynamo. They've made another one called Dynamaps as well that gets map data from OpenStreetMap and gives you basically a basic city model. So definitely worth looking into all their work. And they also have a tool for model comparison inside Data Shapes as well. But what we're looking at it for and what they're probably most popular for is their user interface package. So we're just going to do a demonstration on what is possible using the UI package from Data Shapes. So we'll just get a little demonstration again. Okay, so I've just got a little 5-minute video where I sort of show the Data Shapes package and how it works, and then we'll apply it to a script after.
So the the data shapes Dynamo package has a lot of sections, but if you go down to UI and then the UI section, you'll see that you've got a whole bunch of inputs or data types that you can feed in. So the way that it works, this is my main user interface, or what triggers the UI to pop up. You can see I'm feeding in a lot of things like the title of the UI. I've got file paths. I've got a sizing section that says how big is your user interface there. But what I'm going to look at first is just all the buttons that you can add to your user interface. So essentially this is a set of Boolean or radio buttons. I'll run this shortly so you can see what they look like. Essentially you set their input name and then you tell them what are called keys and values in some cases, which I'll explain shortly. We've got color pickers and file paths, directory paths, and what you do is you collect them all in a big list and you feed that list into the interface builder. So we're going to take that list and we're just going to connect that to the inputs node of the main UI. And you can see here sort of what they look like. So I'll just quickly, I think, toggle this to true. So there you go. So we've got radio buttons coming up there. We've got booleans, a color picker, and paths. So we're just going to look at keys and values. So note for this radio buttons section, see how it's saying A, B, C? You'll see that's because the keys are also being told to say A, B, C. I'm just showing a color picker there, so you can get a color and it returns the color. You can take directory paths, so I'll just pick any old folder except for a cycle bin. And then you can get file paths as well, so I'll just pick that path. So from there, if I run my script, I think I'm about to. There you go. So you can see that these are my outputs that I'm collecting. So you can see my color, my file paths, and my booleans and my ABCs. So I think I'm just going to explain keys and values shortly. Alright, so this is another type of UI that you can trigger. So we've got what I call model selections. In this case, you can see I've grouped these 4 elements in one. So I've got 4 UI buttons being fed into an input group. So you can sort of subset your UI buttons as well. You can see I've got nodes that let me select edges, faces, model elements. I've got a UI slider that I define using the UI slider node. I've got text boxes as well. Then I've got text boxes that only accept certain types of characters, so they only accept numbers in this case. So you can see down there I've said number entry is false, but then below that I've got number entry is true. And then also multi-line text as well. I think when I run this the first time, I need to set toggle to true. So what I'll do is I'll just rerun my UI and see it refreshes each time. You don't get the same values. So I'm just going to really quickly populate some values in here. And then we run, and you'll see that sometimes if someone doesn't choose something, you get what's called a null, which is like no data. So just be mindful that you may need to process nulls sometimes if people don't run the script properly. Anyway, we'll just refresh our UI again. Every time you toggle that, it basically refreshes your user interface. So we're going to collect some other types of nodes in this one. So we're going to collect what's called a data tree in this case, and you'll see what that looks like. So this is where I talk about keys and values. So note that my keys are arranged from A to Z, and my values are arranged from 1 to 26. So they're essentially not the same thing. So the key is more or less what you'll see in your UI, but your value is what will actually get pushed through. So you can see here my tree structure. So you can set up very complex lists if you have a complex list that a user needs to go through, such as families by category or something like that. You can see my drop down, but then also my list view. So list views are really handy because they're like a multi boolean basically. So if I run this, note that my values that came through are all numerical. So you can see that down the bottom, 9, 11, and 13 came through, even though I picked letters. So that's because my keys were letters and my values were numbers. And that's really important to understand. So you can push through things like model elements, but you can use the key as like the model element's name, so it makes more sense. We're just going to do an image and a little surprise in this one, just to show you how flexible this one can be. In that case, we're just refreshing our script. And check it out, you can do text notes for help notes, and you can even embed GIFs in there as well. So obviously that GIF isn't very helpful, it's just a bit of a joke. So really that could be like a little GIF showing someone how to operate the script. So that's quite powerful. So one really exciting thing that we saw there in data shapes is the idea of stop-start logic. So the ability for a script to be stopped at a certain point and then feed through values after. So this is our basic script we've got. But let's sort of rethink how the script works using data shapes. So you can imagine that what we're going to do really is we're going to take our inputs and they're all going to go to the front. And all the processes are going to come after instead. And what we're going to do is collect all our inputs in a UI. So basically, like, inputs provide the options and our outputs provide the data. And essentially this forms a stop point in our script, which says wait, let the user pick some things, and then keep moving. And you can put multiple UIs in a script, so you can stop the script many times over. So you can collect data, trigger a user interface, collect data, trigger user interface, run the final process. It's very powerful. So it's got all the benefits of Dynamo Player, which is great. But it also does stop-start. It has a play button that triggers the UI. So basically in Dynamo Player, if you hit play, it will trigger the UI to pop up because the script will just start running. So you no longer need Dynamo inputs in Dynamo Player. It's highly flexible. So the order of the buttons, the types of buttons, the way you can make the data look, adding logos, it's very easy to add help as well. So you saw that I could add GIFs, but you can also add a help file in the bottom right corner as well. So we're going to do just a demonstration of how the script would look when we add data shapes to it. I won't show the whole thing being built in data shapes because it takes a little bit of time, but I'll sort of explain how the script has been changed. So we'll just do another demonstration video. Okay, so here's our script with a UI added to it. So you can see we've got a UI here that's basically saying what's the title, which is add, remove, revisions, run script, the size, and then we're just collecting our inputs. So what we're doing instead is we're collecting our sheets in a UI button for a list view in order to pick our sheets we want. We're choosing our revision using a drop-down, and then we're just doing a Boolean input for whether we want to add or remove the sheets. So the way the script runs is a lot more efficient now. We no longer have to worry about sheet sets, which is great. So the revisions are quite simple. We just collect all revisions and we collect their names. So the keys are the revision name, and the values are the revision itself in Dynamo. It's a great example of keys being used there. Sheets, much easier. We get all sheets, and then we get all sheet numbers, all sheet names, make a little sentence that sort of describes the sheet, and then we feed that into our list view so we can pick any sheet in our project. So we do away with having to set up a sheet set. Much more powerful. So that's pretty much the UI ready to go. But what we do then is we collect our outputs. So we take item 0, 1, 2, and then we feed them into the back end of our script. So we're taking the true false, and we're feeding that into our revisions node. We're taking our sheets, and we're feeding that into our list map. And we're taking our revision, which we should look at in a sec. I think we should look at that. Maybe not. Yeah, the revision's going into the same place that it was before. So at this point, we can pretty much run our script as a UI. So if I run this, it should prompt the UI to come up straight away. And there you go. That's our UI. If you don't specify the logo, it just brings up the data shapes logo. So we can pick any number of sheets. We can pick a revision, add or remove. We run, and off it goes. And it's run. So there you go. So it's about the same speed as Dynamo Player to run as well. Maybe slightly faster. But there you go, very, very quick, very easy. And the user is guided entirely by that process instead. So far better. There we go. And you can see there we're collecting all that data to make the names of our sheets, feeding that through. And then we're getting our revisions. So we feed through the revision itself, but not the name is only the key. But that's what we see in the user interface. Much more powerful. And you can see that we're getting, it only tells you the last input in a code block for the outputs, but there you go, there's our outputs. So a list of sheets, a revision, and a Boolean in this case. And that's pretty much it. So I think I'll just boot it up through Dynamo Player as well, just to show you what happened. But it's essentially still functioning the same way that it did before in that case. Okay, so we're just going to close that. We'll go open Dynamo Player. And we're just going to quickly run our script through Dynamo Player as well, just to show that the UI still triggers from Dynamo Player itself. It runs the same way. Again, taking a little bit of time to boot up Dynamo Player. nice if it was a little bit faster in future versions. Okay, so we're just going to again navigate to that folder. Usually it remembers which folder you want to go through, but I think I was testing something on my desktop as well, so that's why it defaulted there. Okay, so we're just going to run our data shapes script, and we should expect our UI will pop up once Dynamo Player's read the script. You can imagine I'm a user that has no understanding of Dynamo. I don't really understand Dynamo Player, but this immediately is something that makes sense to me. I can see my sheets, I can see my revision, and I can say I'm adding or removing. So very simple, really simplifies the process for them. And it runs, tells you what happens, and all your scripts update the model, and you can run it again, pick your inputs again. The only disadvantage between this and Dynamo Player is that DataShape doesn't remember the last thing you chose for your inputs. So occasionally Dynamo Player is more suitable, but I find data shapes is nearly always superior.
Okay, so we've basically seen data shapes in action. So we more or less scrapped our original input strategy, and instead we collect them differently to suit the user interface. So we're pretty much setting up our inputs here, generating our user interface buttons, noting the true false is now part of the button structure instead of an input before that. Building our main UI, getting our outputs, or bottlenecking them as I call it, so collecting them all in one node and then spreading them out to the output and the process. And then the process and the output is large in part the same. Most of the time the output structure doesn't need to change, it's really just the input structure and how you collect all that data before you release it back into the process. So I'm just going to show you 3 examples of using Dynamo, not Dynamo Player, data shapes, and then one using Dynamo Player. Noting in the Dynamo Player example, it's more efficient to use Dynamo Player because I want to keep the inputs that I've chosen. So I'll run through that shortly. Okay, so we've got a few demonstration scripts here. This first one is just a schedule exporter. You can see here I just pick the schedule out of the model that I want to export, and then I just pick where I want to save it to. In this case, the desktop is the default path. So if another user runs this, Dynamo actually understands their name and knows what their desktop is called. And then it just generates a little Excel file that has some predefined templating applied to it. So it means you don't have to worry about formatting your data every time it comes out of Revit, because usually you have to delimit the text and you have to change your column widths because they're all defaulted. And you can add like additional tabs to them as well, such as branding. So just a nice little way to export schedules. As well as that, this is a view and a sheet stripper. So I'm picking parameters of views, and then I'll pick a parameter of my sheet as well that I want to filter out. So I'm going to isolate my sheets based on these parameters and my views based on these parameters. So I'll just open a little help file probably, yep. So obviously this is a placeholder. So typically when I build scripts, I'll actually build the placeholder help file because that path is inside the script. That way later on I can update the file. So here I'm just saying what values do I want of those parameters. So notice that I stopped and started my data twice, which is quite powerful. So obviously I can collect more data that usually in Dynamo Player you wouldn't be able to get straight away. And then I'm just going to delete the matches and I get a little results window. And Dynamo's went and found anything that met those criteria and deleted them. So it's a great way to clean up models as well. Yeah, another option for data shapes. This last one's pretty cool. So I've basically suppressed my Adobe PDF settings so that it doesn't ask me where I want to save things. It just has a default path and it won't show me the PDF when it prints. And that's because I'm going to use Dynamo to batch print. So I'm using a node from the Archilab package in the background, but data shapes is doing all the UI work. So I've got a list view for sheets. I'll just pick a few sheets just to print. It doesn't have to be all next to each other. I'll just pick my print settings, which are coming from the project. And I've got the option to add the sheet name on the end as well. And the great thing about this script versus other tools is that everything is already built into the script for the company naming conventions and numbering conventions. So you pretty much don't have to worry about any setting files that other tools need. And obviously the tool's free as well, which is nice. And there you go. You can see that they're all printing out and off you go. Bob is your uncle. Cool. So that's that. So that's a pretty good application for data shapes as well. And the last one we're going to look at is actually an example where Dynamo Player is more suitable than data shapes. And the reason why this is the case is because in this case I want to hold on to most of my inputs
and only change one of them being the end of my goal, because the way the script works is it finds the shortest route through walls and doors in order to reach another point. So you may recognize that this is sort of a tool in Revit 2020 now, the shortest distance tool. But there's a little bit more control available in Dynamo, and this is in Revit 2019. So I'm actually utilizing this portion of the API of Revit before it was actually integrated into Revit's ribbon itself through a package called Space Analysis. So if I run this, you'll expect that my path, which is actually a railing, is going to reroute itself to my destination using the same process as the shortest distance tool. So yeah, really flexible and a little bit more control than the 2020 version, but obviously the 2020 version is much easier to use. So it was really fun for us to be able to access that before it was a part of Revit's main toolset. Got a little sort of sneak peek. So there you go, you can see a lot of applications for data shapes and user interfaces, but we're just going to look at some other small packages really briefly, just for further learning if you're interested. So one of them is called Mandrill, which is quite similar to actually a tool called Power BI by Microsoft. But this one runs directly on the back of a Dynamo script, so it can generate metrics and graphs and report them and print them out to PDF. So definitely worth looking into further. There's a lot of types of plots and graphs that you can run on the back of a Dynamo script using this for immediate reporting. Obviously Power BI is probably more powerful for data visualization if you've got the time to take your data and then process it. But this is a nice quick way to get a little feedback of what's happening in the Dynamo script. Synthetic is a tool that's able to interact with Revit dialog boxes directly. I believe it can even tell dialog boxes what to do. So you may actually find out that there's the option here to semi-automate some batch tasks by prompting dialog boxes when certain things pop up. But definitely worth researching. And of course, I've got a YouTube channel as well, which I guess you're watching right now, but the people there didn't know this at the time, where I teach a lot of things such as learning Dynamo and Dynamo tutorials and also Revit tutorials as well. So thanks for watching it. Thanks for listening. So if you've got any questions or feedback on the presentation or just comments, feel free to leave it down below. If you're not already following and subscribing and you made it through this presentation, hopefully that was motivation enough to join my community. And thanks for watching. Hopefully I'll see you in the next video. Thanks. Take care. Bye.